Something I've been noticing is that we tend to think of reliability sometimes in very black and white terms, but we can also be thinking about how we can deliver better experiences by fixing those little nagging issues.
Well, I was visiting Seattle about a month ago, presenting at SRECon while I was in Seattle. The client asked me to come and show them how to become better users of Honeycomb. The demo was going fantastic. Everything was fine. And they asked me a really interesting question. Hey, we sometimes have some really slow running requests or traces. How do you find those slowest running traces in Honeycomb? How do you debug it? So I just went into one of our main environments and I typed into the Honeycomb query builder. In fact, just be part of the Honeycomb experience where you can get automated assistance with writing a query. And I typed in what are the slowest traces in this data set and automatically constructed this for me. They automatically constructed P99, P95, P50 max, and it also was grouping by name. All the things that you would expect that an experienced developer would be able to do. I'm scrolling through and I was like, wait, this is wrong. This is really bad. So it's sorted by the P99 and you're like, okay, ping kennel has a duration of 60 seconds. It's a span that takes 60 seconds every single time. Okay, that's not surprising. I expect that my process that runs once a minute and takes a minute will take 60 seconds.
Minute.
But I was shocked to see this number here. This number here, let me zoom in for you. This number right here, the highest number of milliseconds that a Honeycomb query run, not a batch process, something that's actually interactive to our users, there was something that took 87 million milliseconds to run. That was really surprising because you take off 3 digits, that's 87,000 seconds. That's surprisingly close to 86,400 seconds per day, which I have memorized. So it means that we had a request to fetch results from Retriever that took a full day to run. I could not get that out of my head. We wrapped up the demo within 2 or 3 minutes afterwards, and I was just like, hey, how many of these queries exist? I actually went and asked a follow-up question. So I said, homing in just on Retriever client fetch, show me all requests that have more than 1 million milliseconds of latency. And then this pulled up something really interesting, because I said also group by the trace ID. I want to see how many distinct requests are there. Is it a lot of requests? Is it fewer requests? Odd thing that I saw was that there was no error. That was really surprising, that it succeeded after an entire day. But even these ones here, taking 6 million milliseconds, 3 million milliseconds, they're just taking way too long. But I was able to observe some interesting things. Like I was seeing these all come from our service that is supposed to handle triggers, like the thing that sends you an alert if your threshold is crossed. Those triggers are evaluated typically once every minute or so. So why do we have a request taking an entire day or even like a few hours? What is wrong to generate a request that runs for almost an entire hour? I quickly went to serious follow-ups and I was like, here's what I would do if I were debugging this. And previous to agentic development, I would have just said, you know what? I'm going straight from this customer meeting to a conference. I'm going to be head down with the conference. I'm just going to drop a note to the team responsible for this. Maybe they can dig into it further. But instead, I started looking more deeply at it. What I started doing was I started looking specifically at this one specific trace to see what was going on with it. Like, why was it so slow? And in fact, now I'm doing this live. This is not a recycled query. This is now a fresh query. So now I'm going in and I'm saying for this one specific trace ID, just show me the trace. Show me what happened to cause that to be so slow. Was it actually running up our AWS Lambda bill? Was it sitting there deadlocked? Was it waiting for something that was never going to happen? Hey, what's going on with that? It basically was talking to a worker that was never going to come back. So I jotted a brief description of this down for Claude Code to look at. And Claude Code said, hey, here are 3 problems that potentially might cause your Retriever client fetch spans to be slow. One of the problems was that we were using gRPC and that we had upgraded gRPC past a certain version, and that newer version of gRPC broke backwards compatibility really badly. It used to have a parameter that said with timeout, where it would guarantee that if your request ran longer than this, it would stop the request, it would return an error. But when we upgraded past gRPC 7.9, it suddenly stopped doing that, and it suddenly was allowing requests to last forever. Secondly, it turns out that we were not correctly handling requests that were taking longer than expected, because when a new minute comes around, you want to stop all the queries that are in flight. You want to go and initiate a new round of queries. And finally, we had a problem where we were not correctly recycling and reusing streams between different workers. I was able to directly plug in this trace that took 24 hours and 12 minutes. I was able to plug this into Claude code with Honeycomb MCP. I was able to look at this data and say, here's what I diagnose is wrong with this specific trace. Parts of it that were going to succeed, they completed in like 30 minutes, 42. Yeah, they completed in less than a second. And then it just sat there until the process eventually was shut down. So I think this is really cool because we know that language models have a tendency to confabulate. They tend to say, this is your problem. And they're very confident. But it turns out that when you can actually link them to specific examples of failing queries, so that was one specific trace, but I can pull up the other two traces and I'll wait for that to load up. But it shows 3 different failure modes. One of them was that we weren't propagating timeouts. Another one was that the gRP stack was stuck. The other one was this failure mode that I mentioned where it would start connecting and it would never time out while setting up the connection. And I was able to, just from the description of, hey, like, here's a Honeycomb query link that has a link to 3 or 4 different, it was literally just taking the top 4 Flow queries from here. I said, Claude, fix this. It's your responsibility to be able to dig around this code base and see what's going on. So this is the one that took 1 hour and 39 seconds and was a gRPC state machine error. This one is, I was trying to connect to a host that had already been shut down, 50 minutes, 1 second. So guided by the information as to what was actually happening in production, we were able to squish these 3 separate bugs that were all problems in how we're initiating connections. And look, let me be clear. This was all well within SLA, the slowest 0.0000. Like these are literally the slowest 5 queries in our entire system over a month. You can rest assured that we are executing your triggers 99.9, but the slowest triggers, we still care about the experience because this kind of thing shouldn't be happening. Claude identified the problems with some guidance and direction from me. Part of the thing is you have to identify also when a fix is on target, when it's going to have potentially bad downstream consequences. That is my job as a principal or distinguished engineer to do. But Claude put together the fixes and it was clear these are the 3 situations that it's solving that we've really actually seen in production. So it was like, hey, here are some additional issues to fix. And my colleagues went through and had a look at this and they identified some nits and we fixed it and we merged it. So what do I do next once I've successfully merged that code? I want to see, did I actually fix the problem? So one thing that I did shortly after that was I said, okay, I have merged this now. It is March 25th, I think. Yeah. I merged this on March 25th at 12 p.m. By the way, this was during the conference. I was listening to talks with both of my ears, and then every now and then I would glance at what Claude was doing. So I'm sitting there, demo is Monday, Tuesday, Wednesday, and on Wednesday, finally merged the fix. 3 hours after the flow request lands, I'm like, okay, why don't we zoom in on this? So I land my fix at noon. It releases by 1 p.m. Hey, look, there are no more of these big spikes happening afterwards. Why don't we just go ahead and dig into some of those spikes and see what's going on? So this is the kind of manual investigation path where I'm saying, okay, requests are taking no more than 2 or 3 minutes. This is good. Sometimes a request that kicks off every 15 minutes. You can let it run 2 or 3 minutes. That's okay. So I tapped myself on the back and I was like, good job, Liz. High fives, Claude. But I wanted to be sure. So I actually asked Honeycomb Canvas about 1.5 hours after I landed the pull request. And I said, hey, has the performance actually gotten better? So I asked Canvas, which is our agentic visualization tool, to go ahead and run an analysis to say, has the P50 and P99 latency gotten better? And it was like, hey, your error rate is up, but we expected this. The queries that were succeeding, but taking 24 hours, now we're actually timing out and failing. This is good. But it said, you still have a problem. It said, you still have a problem of queries that are failing with transient failure. And yes, I as a human could have run bubble up myself to go and identify what's shared in common with the transient failure requests. But Canvas was actually able to run that and interpret it on its own. It runs the bubble up and it says, hey, this is happening only on requests, only for requests where the process has been up and running for just a couple of seconds or minutes. So this means that you have a bug in your code, which is not correctly accounting for the fact that you might be trying to connect to an instance that's not up yet. And I said, okay, that's really interesting, but shouldn't we only be shutting down one of the 2 redundant workers in a pair at the same time? That's the whole point of this, is that we always keep one running worker. What's going on? We fixed timeout behavior. We fixed the getting stuck in transient states behavior. And yet we are still connecting to machines that have just restarted and are not available to serve. So it turns out that we as a team, we had misunderstood the gRPC stack yet again. So I draw your attention now to, so this graph again shows before I landed the fix, these were just timing out. But now after I landed the fix, suddenly we're having a whole bunch of these transient failures. Okay, what should we do about it? Maybe sending the timeout to 2 seconds. It used to be 2 seconds and it was ineffectual. It wasn't actually timing out. So maybe we should set the timeout to 10 seconds. Maybe that's a more generous limit that makes sense if we actually enforce it. The other problem was this. We were not correctly detecting hosts as unavailable while they're still spinning up and catching up. As soon as the host was detected as being reachable by TCP, we were starting to hammer it with requests, where we really needed to wait for it to return a health check success status before we declared it to be up and running. So later on that week, so I find those further problems on the 26th, and I land the fixes on the 26th. And then again, I'm watching production and I'm checking and I'm saying, oh, hey, look, that spike of errors that happens after every deploy, it's gone down to basically almost nothing. And after I landed an even further set of fixes, oh, hey, it's gone. But again, trust, verify. So I come to this Canvas investigation a week later and I say, I think I fixed it. Come and have a look at this. So it says 0 errors, completely clean. So your fix is working. There are no transient failures, no Connex deadlines, well connected. And then it drew all that behavior onto this graph where I could get onto the same page as the tools to actually verify, did the readiness probe change work?
Amazing.
Yeah.
And you were able to conduct this whole investigation while attending a conference. What would have happened 6-12 months ago if you'd found a problem like this? What would the result likely have been?
Then within SLO, that's a low priority ticket. Maybe if we get a new joiner on the team, we'll help them look at it. But this seems hard. This seems really annoying and difficult, and it's not really affecting a majority of customers. So we're just going to let it go.
Absolutely. And yet, so you'll find that by using these tools like MCP and Claude together, I would say the size of the too hard basket has shrunk considerably. And what we're able to actually take on and look at seriously and find fixes to has expanded a lot.
Exactly. It's being able to really put polish into your product. So this is why I push back on the idea that AI is just slop all the way down. You can use the automation to create a whole lot of technical debt and noise, or you can use it to deal with things that previously were, this is too hard or this is not worth bothering on. Now you can actually bother. And now you can actually validate that your fixes have worked rather than introducing brand new problems.